Okay, so now let's talk about object storage, which has become a pretty important storage mechanism in the last 10 or 15 years. It's much newer than the file system that we are pretty familiar with, but this is much more comparable to a file system than it is to an actual database, where with databases, how we structure and filter and search for data is much more important with databases. But with object storage, data is actually stored in a flat way. There's no hierarchy. With file systems, we know we have folders, and then inside of those folders, there can be more folders or there can be actual files and things like that. But with object storage, there actually isn't anything like a folder. Now, popular examples of object storage would be AWS S3 or Google Cloud Storage. Azure has their own object storage. Object storage is pretty common. And with some of these services, they kind of give the illusion of a file system. With S3, you can have folders and then have files inside of them. But in that case, the folder is actually just a part of the name of the file. It's a way to kind of give you that illusion, but there actually aren't hierarchies with object storage. All of the objects in S3 are stored in a flat way. And when we talk about objects, the predecessor to object storage was blob storage. And when we talk about objects, we mean blobs. Blob stands for binary large object. Objects gives us the OB. So we have blobs. These are large objects. Typically, we're talking about media, things like images, videos, maybe a database backup, which is not, media, but it's a large object. We store files, typically not like just a regular text file, which we expect to update, because when we put files and objects in object storage, we can write those files, we can add those files, and then we can read that file, but we can't edit that file. We can't update a file. And that's one of the trade-offs with object storage. We cannot update things that we add. Object storage is optimized to store a large amount of objects in a storage in a flat way so that there is no hierarchy, so that we can immediately find objects that we have stored, sort of like a hash map where every object has a unique key. So that gives us a very quick way of accessing that file. That's kind of a parallel from object storage to hash maps. And another parallel is that we cannot have duplicates in hash maps. And that's actually a similarity with blob storage and object storage as well. Because with S3, you need globally unique names. It's not enough to have a unique name in your S3 instances, but actually, if you have a name conflict with anybody else who's using S3, that doesn't work either. You have to have globally unique names, and that's kind of where this comes from. Now, enough about these details. Let's talk about actual use cases. From a design perspective, we don't really need to know much other than if we're storing large files that we need for our application, things like images and videos and other types of media or anything for long-term storage in general, we could, of course, use our database. We could store images and videos inside of a database, but it doesn't really make a lot of sense. Are we ever going to be querying based on image or a video? Well, we might want to use some metadata related to an image, like the name of the image or information like that, some tag related to the image, or a video name, a video title, some attribute about a video. We might use that. And that type of metadata, of course, we can store it in a database, but videos and images, these are large files. We could get into gigabytes when we're talking about videos. What sense does it make to store that in a database? It's going to slow down our queries, increase our storage, and we're going to be reading and writing from our database a lot. And having these in the format of a database doesn't make a lot of sense either, since if a user wanted to see an image or a video, we'd have to read that from the database, from our application, and then from our application send that back to the user. It's better in this case to use object storage. So assuming we had these files in a flat way in some object store like S3, for example, the interface for reading and writing files from an object storage is actually with HTTP. So we don't have to query anything. We don't have to write any SQL. We don't have to filter things. We don't even have to read the entire database or object store. We can actually just make a network request to S3, our object store, ask for whatever file name that we have. It's going to be globally unique, and we will configure our our object store so that we are the only ones who can actually access this file. We won't go super in depth into the security issues, but assume that there is some kind of security capability there. So via HTTP, we get back a video or an image, and then we can send that to the user. So this is a much better way. Object storage makes sense. We can easily find these large files. That's exactly what it's optimized to store, these large files. We have a better interface for using them, HTTP. So that's just a much better way of doing things. And typically with system design interviews, anytime you have large files, you'll mostly be using object storage for them. If you're not already familiar or haven't used something like S3 before, you can kind of just imagine something pretty similar to Google Drive or Dropbox. It's just a bunch of files and images, similar to a file system, but we don't have folders, or at least we have the illusion of folders, but we do not have to search for a file in a file tree. Just knowing the file name, we can kind of use that similar to the way we use hash map keys. So object storage is optimized to store a large amount of large files. And from a system design perspective, these are pretty easy to reason about.